Okay, dear students, I have already explained negative deviation and positive deviation. Now let me illustrate by plotting the graph for negative and positive deviation. First is the positive deviation and another is the negative deviation. It's alright. So by plotting the graph, just you draw the Raoult's law for volatile solute. It is the vapor pressure, and this side you write the mole fraction. Mole fraction, solute equal to 0 and maximum 1, solvent that is the 0 and maximum 1. So far as this is the P naught A, already I have explained in my earlier class. This is the P naught B and it is the formation of the solution, solute plus solvent. So far as positive deviation is concerned, the resulting vapor pressure should be greater than the individual components. That the elevation of this graph showing this is the positive deviation. PA plus PB is greater than P naught A chi A plus P naught B and chi B. It's alright. Now dear students, just you explain the graph by taking Raoult's law once again. It is the vapor pressure versus mole fraction, that is the 0 to 1, and solvent that is again equal to 1. P naught A and this is the P naught B. This is the formation of the solution. It is the negative deviation, so the resulting vapor pressure should be lesser or depressed right from the genuine line of the Raoult's law. PA plus PB is lesser than P naught A chi A plus P naught B chi B. So question may put in your paper, why acetone and chloroform show negative deviation but ethyl alcohol and water show positive deviation? By taking the differences, and you can explain with the help of graph. I made it clear to everyone. It's alright. Now the next is the very important aspect of this chapter is colligative property. It is made by two words, co plus ligare. It is a Greek word or Latin word that means ligate to binding force. It is the property of dilute solution which depends upon the number of particles but independent upon the nature of particle. So colligative property is directly proportional to the number of particles but inversely proportional to the molar mass. For example, if I say, better to explain by taking a very good example. This question asked in the previous CBSE paper. I say 1 molar NaCl and 1 molar glucose. Anybody can tell me which has more colligative property? Yes, of course, because of colligative property directly proportional to the particles formed in the solution. So far as NaCl is concerned, it is ionized to form Na positive and Cl negative, two particles. It is electrolyte, but glucose is non-electrolyte, so it will remain 1. So this is, it has more colligative property than the glucose. I give you another example, NaCl, CaCl2, AlCl3 and K4FeCN6. Which has more colligative property? Your answer is very obvious and very simple. Potassium hexacyanophyllite, under splitting to form 4 plus 1 5 particles, it will 3 plus 1 4, 2 plus 1 3 and 1 plus 1 2. So I have made it in the increasing order, ascending order of the colligative property. Tell me the another very important part of the colligative property is the next important part of the colligative property is it helps to calculate the molar mass of non-volatile solute. So all the colligative property is found to be inversely proportional to the molar mass of non-volatile solute. Solve one question which has more colligative property. 1 molar solution of urea, 1 molar solution of glucose, say 6H12O6, and 1 molar solution of sucrose, C12S22O11. Each one of them will remain one in solution because all are non-electrolyte, but urea has molecular mass 60 and glucose 180 and sucrose 342, and colligative inversely proportional to the molar mass. Here urea has more colligative property than glucose and then sucrose. So these are the very rich information about colligative property. Then question is types of colligative property. So in my next class I will discuss types of colligative property.